Hello dear students, we continue our work of solving the unit test questions which are asked in Thadomal Sahani Engineering College SEM 3 Automata Theory subject. Check this question, derive this string AAA using leftmost derivation LMD and derive this string ABA, BAB, BA using RMD rightmost derivation and also draw parse tree given this grammar, context free grammar. Now in this context free grammar, these capital letters S, B and capital A, these capital letters are called non-terminals. So in our grammar, non-terminals are S, A, B, three non-terminals, and these small letters are called as terminals. So terminals over here are A, comma B. Only two small letters are there, A, B. Here also A, B. Okay, and this particular line is called production. So S derives, this is read as S derives AB like this, and this is read as or S derives BA. So actually these are two separate productions. S may derive AB or S may derive BA. How will you write this? How will you see this production? A derives AS or A derives BAA. A derives BAA or A derives A. And same for this third, capital B derives small b followed by S, capital B derives small a followed by two capital B's, and capital B derives B. Now what is the problem is that given this grammar, we have to derive this string from the grammar, okay, and two methods are there, leftmost derivation and rightmost derivation, okay. Both can be used to derive the string, and also we can show the derivation by using parse tree. Trust me, the problem is very simple, okay. So I have written the problem again over here. We want to derive AAA BB using leftmost derivation, derive ABA, BAB, BA using rightmost derivation, and the grammar given is this. Now this capital S is known as start symbol. The first capital letter that you watch on the upper left corner is start symbol, and derivation must start from start symbol S. So how do you show LMD, leftmost derivation? While solving the problem, I will tell you the meaning of leftmost, why it is known as leftmost derivation. Note, the string to be derived is AAA BBB, okay. So start with the start symbol S. S can derive like this, either small a followed by capital B or small b followed by capital A. You tell me, we want to derive this string, correct? What is the first terminal we want in the string? A. So obviously when we use S, capital S, we will not use the second production BA. Suppose I say S derives BA, then I am in the event of deriving a string which begins with B, but I want a string which begins with A. So the production that we will use is, we will say S, please give us small a followed by capital B. This is the production I have used, okay. Now success is, after this step, the success is that we have got first A generated of our string. Remaining string AA BBB, one A has been generated, remaining string AA BBB has to be generated, correct. And only this capital B can give us something, because B can give us, note, B can give us something, okay. Are you reading it like this? Now B should be expanded, okay. So what we will show then, below this, S is over, okay. S has been used, it has given AB. Now A will remain as it is, but B should give us this remaining string. Somehow this double A and triple B is remaining. A is generated, first A. Capital B, should somehow give us this string. You tell me, if you are watching this production, if I substitute this B with BS, the first production, observe, B gives BS, but then that will be wrong, because then the second letter I will be deriving is B, but the second letter I want is A. Observe, after A I want A. So it is obvious that when you substitute B with the right hand side, when you substitute this B with the right hand side, ABB is the best production. ABB, correct? Okay. So what are you successful in? Generating first two A's. Yes, first two A's are generated now, this A and this A. Now somehow, these two B's, these two, should give us single A, triple B. Think of this. What have you generated now? A generated. Now the string pending to be generated is single A, triple B. And we have double B pending in our derivation. Somehow these two B's must give us this remaining string. Okay. Now, when you read this, this string from left to right, and if you always substitute the first non-terminal which comes from the left hand side, if you take in that order, it is known as leftmost derivation. Somebody will say, sir, what you do is A, B, B, B. This is what we are having. Then first you substitute this B and then you substitute this B. That means you are coming from right hand side. Then it is known as rightmost derivation. But in the pending part, A, double B, if you go from left to right and if you give priority to the first non-terminal and substitute it, then next non-terminal and substitute it, it is known as leftmost derivation. Okay, where were we? Now we have double A generated, first two A's are generated, and this is the string pending, A, triple B, and we have two B's left, and we will always give priority to the first B, leftmost derivation. Okay, we want A again, isn't it? Watch this, we want A again, and the only production that B can give A is ABB. I hope you are getting. Leftmost derivation, A, and we will then substitute this with this B, we are substituting first B with A, double B. And note that this B is still pending. What we have done is, this first B, has been substituted as ABB. Agreed? And this B was still there. Okay. Now we have this string. Success is, we have generated first three A's. First three A's generated. Correct? And now watch. What have you generated? Come again. Just check. Triple A is generated. Somehow we want this triple B to be generated now. And what do you have now? You have three B's. Just check. Capital B's. Somehow, these three non-terminals should be substituted with the correct options so that we get B followed by B followed by B. Are you seeing B, capital B can give single B? That's it. That means these three capital B's can be one by one substituted as follows. Triple A. Remember, we are doing leftmost derivation. So the first B substituted with B. What remains is BB. The last two B's. So this B is also generated. Now next, triple A, small b, and this first B, leftmost derivation, substituted with B, second B generated, and the third and the last one remains as it is, and the final step is triple A, double B, and this B substituted with B. This is leftmost derivation. If you write it properly, it should be S gives AB, then double A, B, B. I am just writing the steps again neatly. Then A, B, B, B. Then A, B. Two B's remain. Then A, B, 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 and then A, B, B, B. Now, whenever you show this leftmost derivation, in your answer paper, what you should do, you should write which production have you used. Here, which production have you used? S gives AB. Oh, I'm so sorry. S gives AB. Here, which production you used? B derives, isn't it? This B was substituted with ABB. That's how you got this step. So B gives ABB. Then which production you have used here? Come on, again this B. This B was substituted with ABB. B derives ABB, correct? Then which derivation you have used here? B gives B. Here B gives B. Here again B gives B. That's it. This is leftmost derivation for the string AAA for our grammar. Got it? Okay. Now, second part of the question asks that derive this string ABA, BAB, BA using RMD, rightmost derivation. Okay. So, just give me some time. I'll just clean the board because I want that grammar to be there in front of me so that I can readily refer that. Okay. By the way, you can pause the video and you can find out RMD will be absolutely easy now for you. Just read the grammar and check which are the appropriate options so that we will get the string that we desire. Okay, which is the string we want? Here we go. We want AB, we want ABA, BAB, BA. Correct? This is the string using RMD. And remember, the derivation must start only with start symbol. Correct? Okay, tell me, if you start with start symbol S, what is the first letter you want? A. So obviously you will not go for S derives BA, correct? Again the same story, because the first letter you want to generate is A, so you will use S derives AB. Done. First letter is generated. Now somehow this B, non-terminal, should give us the remaining string. Correct? Okay. And we are using rightmost derivation. So take from the right hand side, take the first non-terminal, and here we have only one non-terminal. But if there were many non-terminals, always take that non-terminal which comes first from the right hand side. Okay? Right. Okay. Here we don't have any problem, we have only one non-terminal. Okay, now tell me, when you go for this production B, what are the substitutions possible? BS. Suppose we use this BS, the first one, BS. Wrong, because then first two letters generated will be AB. Oh, I'm so sorry. It is true. I'm so sorry. We want AB, isn't it? Success. We have to use this BS. Suppose I use the second option for B. I say no, I will substitute B with ABB. ABB. Look, this is also one of the options, ABB. But then I will get first two letters as AA, but I want first two letters as AB. Then the appropriate option to substitute B here is BS. Done. Success. We have now generated A and B. Now we have one S, one capital S pending. And somehow that capital S should give us this remaining string. This remaining string. Just a second. Correct? Note, we have generated AB. String pending now is ABABBA, and we have only S pending, capital S in our derivation. Somehow this S should give us this. Tell me, go back to S. First production. You will obviously use AB because you want A now, isn't it? You cannot use BA. I hope you are understanding. So the next production we will use is AB, and S gives us AB. Successful in generating A again. See, first three letters are generated. So are you now following what we have generated? What have you generated now? Just check. We have generated ABA. Notice, we have generated ABA, correct? and some way or the other we want BA, BBA to be generated, and we have, just a second, I lost the screen. I'll just restore the screen again. Give me a second. Just a second. So what was the grammar? The grammar was S gives AB, S derives AB, AB or BA. I am just restoring the screen. You can forward this BA. Then what does A derive? A derives AS BAA, AS BAA or small a, that is terminal, and B derives BS ABB, BS ABB or B. And what are you supposed to derive using RMD? Using RMD, you want to derive ABA BAB, ABA BAB followed by ABA BAB BA. Okay. So what was our first step? S gives AB. First A derived. Now somehow B should give this, and B, if B is going to give this, then we want the letter B. Then the only production we can use is this. So A gives, A is still there, but B gives BS. Correct? Capital S. So AB is generated. Now AB is generated, and this part of the string is pending. And now we have S, capital S. Capital S. Capital S should give this somehow. That means we want the letter A to begin with. So the only production we can use, S gives AB. AB. So we have now derived ABA. Are you understanding? First three letters. And now remaining string we want to derive is BABBA, and we have B. Remember, we are using rightmost derivation, and from rightmost, B is the first non-terminal. Anyway, there is only one non-terminal here, so there is no problem. But if there were many non-terminals, we will always take first one which appears from right side. Okay, tell me, ABA generated, we want B now, somehow we want this B. Then the only production we can use is B gives BS, ABA BS. So we have now generated ABAB. Watch this, ABAB, and the string pending is ABBA, Abba. S is now pending, capital S. Okay, what do you want? A. Correct? A. So obviously we will use S gives AB, right? So we will have A, B, A, B, A. What was that? S gives AB. Okay. AB. So now we have generated A, B, A, B, A, and the string remaining is B, B, A, and only B is pending. Tell me, we want B now, isn't it? In our rest of the string we want B. Obviously we will again use B gives BS. So AB, AB, A, and then BS. Now we have generated AB, 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 and only BA is pending, and we have S, non-terminal S. Correct? But we want first letter to be B now. Observe, there is the second option here with S. S can give us BA. S can give us BA. So we will substitute this as A, B, A, B, A, B, B, A. So we have generated A, B, A, B, A, B, B, and only A is pending, and we have A, capital A, and you observe capital A can give single A. That's it. Once we get this single A, A, B, A, B, A, B, B, A, then no non-terminal is now pending, no capital letter is pending, and we have got our string. But don't forget, whenever you write this, derivation, you should write which production you used. Here, you substituted B with BS. This B was substituted. So B derives BS. This production you have used. Here S derives AB. Are you following? This S was substituted with AB. Here B derives BS. What about this? S derives AB. Here B derives BS. Which production we used here? S derives BA, and here we used A derived A. This is rightmost production RMD for the given string. Simple, isn't it? Very easy. But one more thing they say is that draw the parse tree. Now it is so simple to draw the parse tree. Okay, what you do is, once you have written these productions, once you have derived this, see, derivation is in front of you. Okay, how do you draw parse tree? You show S as root node. Okay, check, S is the root node. And what is S deriving in the first step? AB. Then show two children, small a and capital B. This represents the first step. Okay. Then in second step, what did you do? You substituted B with BS. This capital B, you substituted it with BS. So this capital B became B capital S. Then in the next step, you substituted this S with AB. Check this, S with AB. So it becomes A capital B. Are you following? Then in the next step, you substituted B with BS, capital B with BS. So you get BS. Then in next step, you substituted S with AB. This S was substituted with A capital B. Then B was substituted with BS. So parse tree is getting developed. B was substituted with BS. Then S was substituted with BA. S became BA. And finally A was substituted with single child A. Single child A. Now you read all the leaf nodes from left to right. This is the leaf node, isn't it? Does not have any children. So if you read it like this, A, then B, A, B, A, B, B, A, A, B, A, B, A, B, B, A. This was your string which you needed. What you are doing is that the derivation that you wrote step by step like this, derivation that you wrote step by step, you are showing it as a picture, nothing else. You are showing it as a picture, okay? Now, have you understood one thing, that leftmost derivation, rightmost derivation, both will have same parse tree. Same parse tree. So it is not like that we will have to think that, okay, this is parse tree for RMD. Then what will be the parse tree for LMD? It will be same. Parse tree will be same. Okay. By the way, just check. We had our first string that we wanted to derive, correct? Recall what was the first string? First string we wanted to derive using LMD was AAA. Correct? AAA. Okay. I am drawing parse tree for AAA. Right? Okay. See, so simple. I want to derive AAA using LMD, but I am drawing parse tree. Derivation starts with S. Start symbol. I want AAA. So I want A first. So I'll say, okay, S derives A capital B. Done. First A is derived. Now, capital B, somehow should give us this part, this string. Then capital B should be A, B, B. Only then I will get second letter A. A, B, B. Now these two B's are pending, correct? Now don't think of LMD or RMD. When you are drawing parse tree, you can use any LMD or RMD, you will get the same parse tree. I repeat, when you are drawing parse tree, don't think of LMD or RMD. Simply take the first non-terminal from left hand side. Okay. So what will you substitute B with? Obviously again A, B, B. So are you getting first three A's? You watch. Yes. Just check. First three A's are now generated. First three A's are generated. Now these three B's are pending, and you know B can give B. So each of these B's one by one will be substituted with B. This last B is pending, you watch here. This will be substituted by B. Now if you see all the leaf nodes from left to right, we have A, B, 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 done. This is the parse tree. Okay. Now I have one more question here, rather not I, it is asked in your test sequence, that we want to derive this string, you see, A plus B bracket, and this star is here multiply, not raised to, it looks like raised to, into A plus B. This is the string I want to derive from this grammar, okay. See, they have asked leftmost derivation, rightmost derivation and parse tree. So there should be three answers, correct? Three answers must be there. Okay, let's try drawing parse tree straight away. From where will the derivation start? E. E is the start symbol. So I will start with E. Okay, tell me what do you want? This string? Correct? This, now you are constructing parse tree. Don't think of LMD or RMD. I hope you are understanding. Don't think of that, LMD or RMD. Now you tell me, we have this star and we have this plus. Okay, star and plus, two things are there. Fine. Now if you are watching E, E can either give E plus T or E can give T. Either of this. E can give either E plus T or T. You can, that means you can write this as E gives E plus T. This way you can write, or that is entire production I have written as children, right? Or you can say E gives T and then continue. Either E gives E plus T or E gives T. Which is the production that you will use here? Which is the best production that you will use? Okay, let's try. We'll use E plus T. E plus T. Now do you understand that in our entire string, you know, we have at least have success of deriving plus. Now somehow, you know, this portion to the left of plus should be derived by capital E, and this B to the right of plus should be derived by T. Are you understanding? E plus T is now pending. Look at the lowest level, E plus T. Plus is generated, and what is to the left of plus? A plus B into A. This portion is pending. This should be given by E now. And what about plus? Right of plus is B. This B should be given by T. Somehow we should get this, correct? Okay. Now, don't think of LMD, RMD again. Think of this E. What can E give? E can either give E plus T. Now, suppose I substitute this as E plus T like this. Oh my God, I will get second plus. But in this entire expression, plus is only once. I don't want plus anymore now. So this is not a favorable production for us. I don't want another plus. So what can E give us? T. I will substitute this E with T. Okay. Done. So now what I am telling, just check. Now what I am saying is that I have generated this plus. plus is generated. Somehow, you know, this t plus t is now pending. This t plus t. Somehow this portion should be given by t and b should be given by t. Okay, let's see t. T gives t into f. Okay, I will then write t gives t into f. Fantastic. And now you watch, t next time gives f. T gives f. And you watch, f gives bracketed e. How will you write? Come on, come on. How will you write? F gives bracketed e. Bracket e bracket. Oh, I'm so close bracket. Close bracket. Correct? See, we are gradually getting the string that we want, isn't it? Okay, but we are using only valid productions. Now, what are we successful till now in generating? What have you generated? We have generated bracket. Yes, bracket is generated. Correct? Then this close bracket is generated. Correct? You will see this asterisk is also generated. You watch this node. Plus is generated. So it's only a matter of a plus b, then this a and this b. How will you reach that? Okay? Fine enough. So you now check that e is pending. This leftmost e, this e is pending. Correct? We can again say e gives e plus t. E plus t. I hope you are understanding. And now somehow this e, you know, should give us this a. And this t should give us this b. Because we are in the brackets now. In the brackets. Okay? So the tree will continue from here. I guess you are understanding. The tree will continue from here. Okay, what did we do? Just spend some more time here. What did we do till now? Let's see. Okay, just check. What we have done is, we started with e. We said we want this plus. So we said e gives e plus t. E gives e plus t. Then this portion will be given by e, this portion will be given by t, plus is generated. Correct? Now we will say e gives t. Why? Why we have used this production? Because we want multiply. So that t gives t into f. Okay. Now into is also generated, but to the left of into, you watch, we want bracket. Bracket we want. How will you generate that bracket? To the left of star, how will you generate? This t can give f. Observe, t can give f and f can give bracketed e. Okay, bracket, capital E, bracket. Now what do you have inside bracket? A plus b. Do you see this bracket and this bracket is generated? So somehow e should give, this e should give a plus b. So we can then say e gives e plus t. E plus t. Correct? Now what do you want? To the left of plus you want a, to the right of plus you want b. So you, in the next step you say e gives t gives f and f gives a. Just observe this. E gives t gives f, t gives f and f gives a. We got this. And here we say t gives f, f gives a. F gives b. Correct? So till now from the left hand side you have got bracket. Next we have got a. See the leaf nodes a. Then you have got plus. Then you have got this leaf node b. And then you have got this bracket. You see this is also a leaf node. Bracket. Then we have got this leaf node. Observe this star. Correct. Now f is pending. And f can readily give us a. See this portion is generated. Then plus is a leaf again. and now T is pending. Somehow we want this B from this T. How will you get? T gives F and F gives A, sorry, B. So T gives F, F gives B. So we got B also. This is the way how we have drawn parse tree for this. And then they have asked us leftmost and rightmost derivation also. Okay, just make a note of it. I am erasing the screen. What will be the leftmost derivation for A plus B into A plus B? First step, E gives E plus T. Why? Because that's the only, from start symbol, that's the only option we have, E plus T. In the next step, we want multiply. Plus is generated, we want multiply. So we will say E gives T plus T. E gives T so that T gives us multiplication. So this T gives us T into F plus T. Now we have got multiply, we have got add. Now somehow, you know, to the left of this multiply, we want this bracket A plus B. How will you get that? You see, T gives F, so T gives F into F plus T, and F gives bracketed E, okay, bracketed E into F plus T. So we got the bracket, and we are back to E again. Somehow, you know, this A plus B in the bracket should be given by E, but E gives E plus T, you can use this. So E plus T into F plus T. Now can you get A over here and B over here? Yes. You can say E gives T. I continue here. Then T gives F and F gives A. Then this T will give F. Then this F will give B. Then leftmost derivation it is. So this F now will give A. We want A, isn't it? Plus T is pending. That means only B has to be generated, and you have to reach B from T. So T gives F, F gives B. So A plus B into A plus F, and finally A plus B into A plus B. This is the string we wanted using leftmost derivation. Okay. So these steps we will have to write, starting from here and going here. Okay. What about rightmost derivation? A plus B into A plus B, rightmost. First derivation must begin with E. Okay, I'll use 2 pages now. E. E gives E plus T, no other option. E gives E plus T. Now rightmost derivation, isn't it? Rightmost. See, we have already got this plus. We want B here. So rightmost derivation, we'll say T gives F and F gives B. Done. This T, rightmost derivation, T gives F and F gives B. We got this last letter we got generated. Okay, but now somehow, you know, see, we got second last two last letters plus B we got, but E should give us this portion. But to generate this portion we want multiply. Then we will say rightmost, it is rightmost derivation. We will say E gives T plus B. Why we have substituted E with T? Because T can give us T into F plus B. Okay, so we got T into F. Now we can generate this A, T into A plus B, because F gives A. Now somehow this T, you know, this T should give us this bracket A plus B. I continue over here. I write this step again over here, okay, just for reference. T into A plus B. But you know that T gives F and F gives bracketed E. So T gives F into A plus B and F gives bracketed E. We got bracket, and from here I am sure you know how to reach A plus B. You can use E gives E plus T again. E plus T into A plus B. Then we want A plus B here. So E gives T plus T remains into A plus B. Then this T gives F, F plus T into A plus B. Finally, F gives A plus T remains into A plus B. Now this T can give us F, correct? So we will have, I will continue over here, we will have A plus F, correct? This T, A plus F into A plus B, and finally this F will give us A plus B into A plus B. This was the string, and we have derived using rightmost derivation. Okay, that's it. These are the two questions asked regarding context-free grammar, CFG. This grammar is also known as context-free grammar. That's it for this video.